This lesson is going to take you through some of the terminology and definitions that you will need in graph theory. The diagram below is an example of a graph. Graphs are often used to represent places and the routes between them, however they can be used in other contexts as well. The points A, B, C, D and E are called vertices, and the lines that join them are called edges. A sequence of vertices that are linked together is called a walk. So an example would be A to B to C to D to E to C to B. So notice that with a walk, it doesn't matter if a vertex is visited more than once, for example, vertex C. It also doesn't matter if an edge is traversed more than once. For example, the edge B to C is repeated later on when we travel from C to B. Pause the slide and on your whiteboard write down two other examples of a walk. If a walk doesn't repeat any edges, it's called a trail. Pause the slide and write down two examples of a trail. One possible example would be B to C to D to E to C. If a trail also doesn't repeat any vertices, it is called a path. So now on your whiteboards, write down an example of a path. So here we have a path, A to E to D to C. We can see that no edges and no vertices are visited more than once. So we've seen that paths can start and end at different vertices. If a path starts and ends at the same vertex, it's called a cycle. Pause the slide and write down two examples of a cycle. So one example might be A to E to D to C and back to A. A type of cycle that visits every vertex on a graph is called a Hamiltonian cycle. We're going to visit this later in the topic when we look at the travelling salesperson problem. Paths, trails and walks can either be open or closed. If a path, trail or walk starts at the same vertex that it ends, it is called closed. If it starts and ends at different vertices, it's called open. So a cycle is another word for a closed path. Graphs are called connected if it's possible to travel from any vertex to any other vertex. This doesn't need to be direct. For example, it's possible to get from A to D, but you need to travel via E. If we delete some edges from this graph, it's now no longer connected. For example, there is no way to get from vertex A to vertex D, so this is now not a connected graph. Here are some definitions relating to the edges on a graph. If there's more than one edge between two vertices, for example, the two edges between vertex A and vertex E, this is known as multiple edges. An edge that starts and finishes at the same vertex, for example the one at vertex B, is called a loop. A graph is called a simple graph if it contains no multiple edges and no loops. If a graph is simple and also contains no cycles, it is called a tree. Pause the slide now and draw three other possible connected trees. So here's an example of a tree. Another possible example here. A third tree. And a fourth. For any given graph, a subgraph can be formed using some of the vertices and edges from the original graph. So from this graph, pause the slide and draw two subgraphs using some of the vertices and edges. So here is an example of a subgraph. And here is a second example. Notice that subgraphs don't need to use all of the vertices or all of the edges. They also don't need to be connected. A subdivision of a graph is formed when you delete any edge. In this case, we're going to delete edge EC. We then place a new vertex between the two vertices of the deleted edge. I'm going to call that vertex F here. And finally, we create two new edges joining the two original vertices to the new vertex, in this case E to F and F to C. Another way of thinking of this is to position a new vertex along an existing edge, thus creating two new edges in the process.